All right, let's get started with example 3, but first, we need to talk about what truth value means. So, truth value, what that means is a conditional statement has a truth value of either true or false. Okay, so every conditional statement can either be true or false, and that's what its truth value is. Now, this is important. Excuse me. It is false only when the hypothesis is true and the conclusion is false. So the only time the truth value is false, only false, this is really important, when the hypothesis is true and the conclusion, or I should use that's what they use, conclusion is false. That is in the conditional statement. That is the only time it's false. So any other variation than this, it is always true. This right here is the only time it is false. The hypothesis has to be true and the conclusion has to be false for the conditional statement truth value to be false. So to show that a conditional statement is false, you need to find only one counterexample where the hypothesis is true and the conclusion is false. All right, so let's go ahead and practice this. Example 3, determine if the conditional is true. If false, give a counterexample. So what A says is, if this month is August, then next month is September. So if the hypothesis is true, okay, if this month is August, so we would have to go back in time and pretend that we were in the month of August. Okay, so if we are in the month of August, what is the next month? August, and then the next month is September. So if this is true, then the conclusion would also be true. So this would be a true conditional. The hypothesis is true and the conclusion is true. Therefore, I'm going to use these, those mean therefore. That means therefore. Therefore, it's a true conditional. Okay, let's go on to B. It says, if two angles are acute, then they are congruent. Okay, so this is the keyword if, so we know that this is our, right, this is our hypothesis, and there's the keyword for showing that this is the conclusion, right? So two angles are acute. So if we have two angles that are acute, we could have something, well, the thing is can we have two angles that are acute? So if that was true, we could have two angles and, you know, they could be, I don't know, 30, that's an acute. And we could have another one, 30, right? This would be 30. So these are two angles that are acute, right? So that's true. Then they are congruent. Well, we have two acute angles and they are congruent, so we would think that this would be true as well. But is there an example where we can have the hypothesis be true, but then this conclusion would be different? And yes, there is. What if we had two angles that are acute, but let's say we had 30, and then let's say we had 60. Those are both acute angles, which means they're, you know, less than 90 degrees, but greater than 0. So this is still true, and are they congruent? Oh, it says if the two angles are acute, then they are congruent. And that is false. That is false. They're not congruent. So this shows that it's false. So this would be the counter example, which would mean that this conditional statement is false. What we have is we have a hypothesis, right, that is true, and then we have a conclusion, which is false. And if you remember, the truth value is only false only when the hypothesis is true and the conclusion is false. So our counterexample would be an angle that is 30 degrees and an angle that is 60 degrees. Okay? All right, good. Let's go ahead and do the next one. This states if an even number greater than 2 is prime, then 5 plus 4 equals 8. Okay. So the first part, if an even number greater than 2 is prime. Okay, so remember we talked about prime numbers. We know what even numbers are, right? 2, 4, 6, 8. Greater than 2 is prime. So prime numbers are numbers that the only factors that they have are 1 and itself. So like 2 is prime because no other number goes evenly into 2. The only numbers that go evenly into 2 are 1 and 2, right? 1 in itself, 2. So it's saying other even numbers. So what would other even numbers be like? 4, 6, 8. So it says if an even number greater than 2, okay, so these are even numbers that are greater than 2, is prime, but there's a problem here. What is the issue is that all of the even numbers that are greater than 2 are all divisible by 2, so they're never are prime. There's no even numbers greater than 2 that are prime because all of the even numbers, they're all going to be divisible by 2. That means they have the factor of 2. So they're all composite numbers. They're not prime numbers. So in this case, the hypothesis is false. Okay. And then when we look over here, then 5 plus 4 equals 8. Well, we know 5 plus 4 is not equal to 8. So in this instance, this is also false. But the interesting thing about this is if we go back up here, it says, when we're talking about truth value, it says it is only false when the hypothesis is true and the conclusion is false. That's the only time it's false. So is that the case down here? Is the hypothesis true? No, the hypothesis is not true. The hypothesis is false. And because of that, it's not false. It's not, the truth value of this is not false. The truth value of this equals true. Now, that is a tough thing to wrap your brain around. I remember the first time I saw this, and the second and the third. It really just doesn't make sense, right? It's like, what is going on? So, I think what I'm going to do to see, hopefully, how this could make a little bit of sense, I'm going to have to bring in my dear friend. And we're going to bring in my dear friend, and his name is Dr. Seuss. And so I'm going to read this Dr. Seuss book to you, and hopefully this will help. By Dr. Seuss. Oh, the things you can think. Oh, the things you can think by Dr. Seuss. You can think up some birds, that's what you can do. You can think about yellow or think about blue. You can think about red, you can think about pink. You can think up a horse. Oh, the thinks you can think. Oh, the thinks you can think up if only you try. If you try, you can think up a guff going by. And you don't have to stop. You can think about schlop. Schlop, schlop, beautiful schlop with a cherry on top. You can think about gloves. You can think about nubs. You can think a long time about nubs and their gloves. You can think about Kitty O'Sullivan Krause in her big balloon swimming pool over her house. Think of black water. Think up a white sky. Think of a boat. Think of belugas blowing by. You can think about night, a night and none up. The birds are asleep and the 3 moons are up. You can think about day, a day and a dake. The water is blue and the birds are awake. Think and wonder, wonder and think. How much water can 55 elephants drink? You can wonder, how long is the tail of a zong? There are so many thinks that a thinker can think. Would you dare yank a tooth of a rinker fink? And what would you do if you met a jaboo? Oh, the thinks you can think. Think of Peter the postman who crosses the lake once every day and on Saturdays twice. Think of Peter the postman who crosses the ice once every day and on Saturdays twice. Think. You can think any think that you wish. Think a race on a horse on a ball with a fish. Think of light, think of bright, think of stairs in the night. Think a ship, think up a long trip. Go visit the Vipper of Vip. And left, think of left, and think about beft. Why is it that beft always goes left? And why is it so many things go to the right? You can think about that until Saturday night. Think left and think right and think low and think high. Oh, the thinks you can think up if only you try. And that is the end of the Dr. Seuss book. So, the reason why I like bringing up the Dr. Seuss book when we're talking about this is that in the Dr. Seuss book, there are all different types of things that are false, right? Zipper the Vep and Buff goes left. All these things, they're all false, and they're all doing these silly things, but in doing these false, silly things in Dr. Seuss, in a way, because it's in the Dr. Seuss world, it is true to the Dr. Seuss world, if that makes sense. So if Dr. Seuss world is an imaginary thing, you can't have realistic things happening in Dr. Seuss world, and that would make it false. So if we're in this crazy Dr. Seuss world where, you know, there's false names and made-up words and all these different types of things, in order for the Dr. Seuss world to be true, we need to continue on the line of all of these false made-up things, because that is the type of world that we're in. So that's the only type of thing that I can explain to you to try to get you to understand how if that hypothesis is false, then the conclusion is false, then it's equal to true. It's kind of almost like living in a Dr. Seuss world. If the world is false and imaginary, then there's going to be imaginary things which are also false, which are going to happen, which make the whole thing true to the you know, the tone of the story, or the setting of the story. Then it makes the whole setting valid, because we're living in an imaginary world, and since we're living in an imaginary world, then imaginary things are going to happen, and so that makes it true to being in an imaginary world. So, but what you need to know as far as this assignment is anytime the hypothesis is false, the truth value is always going to be true no matter what. So even if the hypothesis is false and the conclusion is false, that means for this truth value, that is true. So let's go ahead and do one more example. Check it out, example 3. It says, determine if the conditional, if a number is odd, then it is divisible by 3 is true. If false, give a counterexample. So it says if a number is odd. So if our hypothesis is true, right, and we have a number that is odd, so what would odd numbers be? 1, 3, 5, 7, 9, right? So those are all odd. So this would mean that our hypothesis would be true. Then it is divisible by 3. Well, if we looked at the number 3, 3 is divisible by 3, so we could say that that conclusion is true. But is there an odd number up here that is not divisible by 3? Yeah, 5. 5 is not divisible by 3. 7 is not divisible by 3. So, and if we were to look at, you know, 5 and 7, and there's a lot more, right? We looked at those numbers, and our hypothesis is true. They're odd numbers, right? 5 and 7, they are odd numbers. However, they are not divisible by 3, so that would mean that our conclusion would be false. All right, and that is the truth value. The truth value of this one is false because the hypothesis is true and the conclusion is false. So therefore, the truth value equals false, and our counterexample is 5 and 7. All right, that is it for example 3. We'll see in a little bit for example 4.